In this video, I'm going to go over examples that have a GCF. So basically, it's going to have a GCF first, and then you have to check to see for difference of squares. Ultimately, you always want to look for a GCF first, and if it has it, take it out, and if it doesn't have it, then you skip that step. So, for example, number 21, first you ask yourself, does this binomial have a GCF? The answer will be yes, because the GCF is 2. So I take out the 2, and I end up with n squared minus 36. Now, what's left over, which is n squared minus 36, is a difference of squares. And since that's a difference of squares, I can factor it even further, still keeping the 2, and breaking n squared minus 36 down into the two conjugates of n plus 6 and n minus 6. Now, I am fully factored, and this is the fully factored form of 2n squared minus 72. Let's jump over to 28. So, first thing you want to ask yourself is, does this have a GCF? And no matter what, you always ask yourself that question. The answer is yes, it does have a GCF. It looks like I can take out an 8, and I can take out 1y. So I'm going to undistribute that. Take out 8 and take out 1y. That leaves me with x squared minus 4y squared when I take out my GCF of 8 and y from each of those terms. Now, if you look at what's left over, you have to check one more time if what's in the parentheses is still factorable. So what's in the parentheses is still factorable because what's in the parentheses is a difference of squares. It looks like a squared minus b squared. Both of these are perfect squares, binomial, separated by subtraction. So I can break that down even further into two conjugates, still bringing down the original value I took out of 8y. That will give me x plus 2y and x minus 2y, as that is the square root of x squared and 4y squared, and conjugates. So this is the fully factored form of the following binomial, 8x squared y minus 32y to the third.